Hello everyone, welcome to SVASA's DDE video lecture on MST301 Philosophy, Science and Consciousness. I'll be your lecturer today, Anandaranga. This video is specifically for the July 2020 PCP students. Quick introduction about myself. Anandaranga, my phone number and WhatsApp number mentioned up there. Engineer by qualification, management consultant by profession, currently working in Bangalore. I was also an MSc student just like you all. Finished my course in 2018. Since then, I've been giving this lecture every semester. Basically, this will be my 5th time giving this lecture. This will be the first time though on a video mode. So please do share your feedback so that I can help improve this on my next time around. This is Vasu sir, Mr. Vasudev Rao. He was my teacher when I was a student. This course was one of my most favorite courses. So when Vasu sir left SVASA, I volunteered to at least share my lecture notes as PPTs and eventually now giving these lecture series. Vasu sir taught me a lot, and I'm just able to share snippets and a few bits and pieces as part of this lecture. Before I begin, want to seek his blessings and all teachers who have guided us to where we are today. Om Gurubhyo Namaha. Let's look at our syllabus for this specific course, broken down into 4 blocks. The first block is the history of science. The second block is on modern science. The third block is a peek into the theories of consciousness, specifically the modern theories of consciousness. The last block we would spend some time on the Indian perspective, Indian science, Indian metaphysical thought, and some specific mentions of consciousness related concepts gleaned from Upanishads and our yogic texts. As you could clearly see, there is a lot going on in this subject. The objective of this course is not to cover deep, cover broad. That's the goal. And what I would try to do through these videos would be to give you a broad brush conceptual understanding of each of these keywords and subtopics mentioned here. This should suffice. Now, one or more of you may be interested to dig deep, more inspired from these than from a specific requirement for this course itself. If so, you're more than welcome to dig deeper, study on your own, refer to the additional reference text, and enjoy this course. For those who want to read extensively, these are some of the recommended books. Meditation, Oneness and Physics by Keswer. There is a Tao of Physics by Capra. Dancing Woolly Masters, it's the view of physics from a non-physics, non-science person. So it's a very funny take, but very, very perceptive and very good understanding of science for those who do not have a science background. Science Delusion by Sheldrake gives you an alternate take on why science is not the be-all and end-all. It's definitely a good read. There is obviously Wikipedia and Google and YouTube. Lots of lectures, lots of course material that you could refer to as part of this studies. Feel free to explore. So let us dive in. But even before we get into the core of our subject, let's try to understand whether this course on consciousness is relevant in today's time. This is a nice chart that shows the popularity of this specific term on Google. And you can see that it has been consistently popular over the last many years, right? At least since 2015, when I tried to capture this last 5 years for the worldwide region. The word consciousness has been a very popular term. Even its mention in books has been consistently high. Since the 1900s, you could see that the word consciousness has been very well mentioned often mentioned in books. So it has not gone dead. It is actually at its peak, and then it's been maintaining its popularity since the 1970s, last 50 years. So definitely it's a terminology that is rooted in the society, and it is something that is relevant to all of us. Now, what if you go Google consciousness? What will you find? What are some of the articles that you're likely to find that might be of interest? There is the famous Scientific American, which is an old, very good magazine for the scientific community. In its January 2020 issue, it had a title says, "Does consciousness pervade the universe?" So those are types of articles that you're likely to find. Some other articles. Scientists may have found the missing link between brain matter and consciousness. So there you go. This was speaking about it from a universe, and here there is a link between brain and consciousness. Someone else had an article that says electrons and quarks may experience consciousness. That means every being in this universe has a consciousness to it. The world of artificial intelligence is not far behind. A lot of debates. Can machines be given consciousness as part of the next evolution of artificial intelligence? So as you could see, consciousness is a very, very broad topic and very popular. So with that brief introduction, let's start our actual lecture. Block 1 is all about history of science. You can view this under 3 topics or subtopics. There is the first subsection that talks about the importance of science and the scientific method and the inherent limitations that we also need to acknowledge as part of science. We'll move into ancient Greek and Roman philosophers, and we'll spend some time looking at the scientific progress through the early Christian era, the Dark Ages, and the Renaissance period. So what is the value system of science? Value, worth of something. So science has a huge reputation today, a very positive reputation. It's the strength of science. So the value system of science means what is the strength of science, what made it as strong as it is today, and why it became such a powerful approach in humanity's development. You could attribute it to 4 reasons: universalism, communalism, disinterestedness, organized skepticism. Big sounding words. Let's take a minute to review each one of these terms in the subsequent slides. Universalism means it applies to everybody. There is no prejudice. Everyone is welcome to learn science, practice science, be a scientist. A good example, a classic example, is that of Einstein's life itself. He was actually working as a patent office clerk when he first published his work in a scientific journal. What it means is that he was not a practicing scientist. He was working somewhere else, but he was still allowed to publish his groundbreaking work in a reputed scientific journal. Again, there are always exceptions. Not everybody in the scientific community accepts the universalism principle. Case in point is Philipp Lenard, a German scientist. During the Second World War era, he was propagating what they called as the German science, or how it was superior to, let's say, a Jewish science, things like that. They viewed that there was some aspect of specialization around where science worked. But broadly, in today's world, science is considered in its universalist form. Communalism. Communalism from the word community. Science and scientists form a part of a community, and there is free exchange of scientific information within this community. Of course, there are exceptions. During the Cold War, the Soviet scientists were completely cut off from the rest of the world. So there are situations where political suppressions and freedom of speech, freedom of information exchange does happen even in today's world. But broadly speaking, scientists and the people in science form a large community of free exchange of information. Disinterestedness. Disinterestedness basically means that there is no personal motive, personal interest in the final outcome. Basically, you take a neutral approach. You want to run a scientific experiment, but as a scientist, you should be disinterested from the actual outcome. You have a hypothesis, but whether the hypothesis is proven, i.e., a success, or it is a failure that you are unable to prove what you are after, both should be accepted equanimously. That is the concept of disinterestedness. Again, exceptions within the academic community, scientific academia rather, there is definitely a push to keep publishing articles. While the majority of the articles are all well validated, there are a few who, in the rush to publish, may probably err on the side of incorrect information being purposely published in order to expedite their goals, publishing goals. But this is again an exception more than the norm. What is organized skepticism? Skepticism means you are curious, you are questioning something, you are not 100% sure that you buy into the concept. In this case of scientific skepticism, you are questioning without any bias. You have a neutral view and your criticism has no bias. A classic example is that of peer review. If you are publishing in the scientific community, in a scientific journal, the peer review process ensures that both the author and the evaluator do not know each other. So there is no authority figure overriding. So what is this authority figure who could override? That can be seen from a good example. Long time ago, when Chandrasekhar, famous for his Nobel Prize in Physics in the 1980s on the ideas of black holes, he was still forming his ideas and the math behind it. He contacted the then eminent professor and physicist of his time, Arthur Eddington. In those discussions, Eddington discouraged Chandrasekhar from pursuing his specific hypothesis, and therefore Chandrasekhar did take it at face value because Eddington was obviously an authority figure. However, much later, as he progressed on his experiments, Chandrasekhar realized that his hypothesis, his theories, ideas were actually valid. So he went back, pursued, and he eventually got the Nobel Prize itself. What we can gain from this specific example is that organized skepticism works. However, there could be instances where someone who places too much information, too much value on an authority figure may end up impacting his scientific progress. In the case of Chandrasekhar, his ideas eventually got published, but had he not met that specific road bump, his ideas might have reached the scientific community much earlier than when it actually did. Having understood the value system of science, let's understand the scientific method. It is this scientific method that gives the credibility, that provides the strength to science that it has achieved. The 6-step method is the most commonly accepted scientific method. Starts with an observation, there is a hypothesis, and then there is a prediction of what you expect to see based upon your hypothesis. You go ahead and run your experiments. You accept, reject, or refine your hypothesis based upon how the experimental results fall in. At the end of the day, you have a theory. So let's understand this with a clear example. Observation. Let's say you are a scientist working 300-400 years ago. You observe the tidal wave pattern. That's your observation. You have multiple hypotheses. One among them is you think that it could be because of the moon. Therefore, you feel that whenever the moon is seen large, then you are expecting the tides to be large. So you think, based upon your hypothesis, if it is true, you expect to see consistently high tide on a full moon. Then you go ahead and run your experiments. How do you do that? You measure the tide at different locations, however far you are able to travel under all conditions. Finally, you observe and determine that yes, it is indeed true that moon has a role to play in the tidal wave pattern. So you accept your hypothesis. Rather, you fail to reject your hypothesis is how you would actually say it. But from a general discussion point of view, we can say that you as a scientist accepted this hypothesis and come up with your theory that moon's gravitational pull causes these tides. So that's a good way of looking at the scientific process. A few things to highlight here. If you notice, you have your hypothesis, you don't jump straight into your experimental results. Basically, you need to first explain what the implications of your hypothesis is. In this case, if you think that moon is the reason for your high tides, you should be able to predict what it means. So you're predicting that there will be a high tide on a full moon. So any of your scientific uh, thinking process should also include a prediction. You don't predict after you say tests. You make a prediction before and then you go run your tests, and that will help you validate whether your hypothesis is indeed true. If your hypothesis is proved many times over or it fails to be rejected, then it becomes a theory. Therefore, it is a circular, repetitive process. In case you found something else was the initial hypothesis to begin with, and you found out that you have to reject that hypothesis, then you go back with a new hypothesis. So this is the circular process. At the end of the day, when everything is in perfect agreement, it becomes a theory. And the test of all theory is experiment, as Feynman says. What this means is, without an experiment, you have nothing to prove. If you are unable to prove something, then it could be a theory until it is actually tested, and at which point the theory may have to be revised as well. An example is where the theory cannot be tested with today's apparatus. So therefore, you have to wait for more technological advancements to help validate this hypothesis. So therefore, if you are a scientist and you have an observation, could this be because of? Definitely not because of Neptune, who is creating the high tides. Okay, just like in any other subject, you would need to be familiar with specific terminologies. Science also requires that you be familiar with some specific terminology, such as what is deductive logic, what is inductive logic. You already saw a few terminologies. What is theory, what is hypothesis, what is observation, and so on. So likewise, let's make sure we understand the two primary terminologies: deductive or deduction and inductive or induction. What is deduction? Deduction means it's a top-down approach. As you could see the arrows moving from information to theory. Basically, you move from a general view to a specific view. You can think of this as a murder mystery novel where the detective, right, he's deducting what's going on. So as a detective, you have identified possible suspects and eventually you narrow it down to that one person who you think is sure to have committed the murder. So therefore, you move from a general list of potential suspects to one. The other example is that of induction. In an inductive process, you start with one specific observation and then you give a general pattern to it. Typically, what we do is we stereotype. We think that people from a certain region have a certain behavior. You think people from south have a certain mannerisms, people from north have a certain mannerisms. That's our typical way of inducting. We look at a couple examples of people around us and we make that stereotyping. In the scientific process, this process is very structured. A good example to compare these two: when you fire a rifle, you're gonna see a recoil. So if you were to take the deductive logic in this, the way this deductive logic would have been applied is, you observe for every action there is an equal and opposite reaction, is your deductive logic starting point, top down. You make this assertion. If this assertion is true, then you want to see whether when the rifle is fired, will it recoil. because firing is the action and recoil should be the opposite reaction. So this is how you would apply the deductive logic if this was the example. In the inductive logic, you take one example. You have fired a rifle and you have observed the recoil. This becomes your information. With this information, you make a generalist statement that for every action there is an equal and opposite reaction. This example is not to say that this is better or one is better than the other. The idea here is to use the appropriate approach for your scientific question. Sometimes it's a deductive approach, sometimes it's an inductive approach. The third part of the scientific method is talking about limitations. Broadly speaking, we can think of 4 limitations in the scientific method. The first is that science and scientific outputs are always approximate, they are never perfect. There is non-reductivity in the what part. We will understand what each of these terms mean in the subsequent slides, but just be aware that there are 4 limitations. The third of them says that science is good at a description of reality, not necessarily the experience of reality. And finally, science completely excludes subjective aspects. So what is the first limitation? Always approximate, never perfect. Did any one of you think that science is always perfect? That science is accurate 100% always, forever? Obviously not. And examples we can use to understand this, looking at the evolution of scientific principles. The Newtonian law of gravitation. It was able to explain the celestial bodies far better than anything before. However, when they observed the movement of Mercury, it follows what is called a perihelion, which is a circular motion that goes 1 degree shift every time. So it follows a pattern such as this. Instead of it being a perfect single line, the line keeps changing like that of a flower. So this could not be explained using Newton's mathematical models. When Einstein brought his general theory of relativity, that model was able to explain that. Again, what the takeaway from this is, even though Newton's law of gravitation was able to explain most, if not all, there were these few that it could not explain, and those were better explained with a future model, which was the Einstein's theory of relativity. Does it mean that GTR is able to explain everything? No way. Even GTR, the general theory of relativity from Einstein, is not able to explain some phenomena. So therefore, better theories will prevail as science progresses. Before we take up the second limitation on non-reductivity, we need to again become familiar with a couple terminologies. When it comes to science, we use 2 approaches to answer the what question. What is this? If you ask that, the response could be, you start breaking it into its lower entities. Reducing each entity into another entity is called reducibility. For example, what is this rock? This rock is nothing but it is made up of bunch of molecules. Okay, what is each of these molecules made of? What is this molecule? This molecule is nothing but bunch of atom. Okay, what is this atom? It is made up of electron, proton, neutron, quasars, etc. So what is that made up of? You keep going down and down. So this is the reducibility, reducing each entity to another entity. What is relativity? Relativity is where you explain something with reference to something else, in relation to something else. Black with respect to white. What is red? It is explained with respect to it is not blue, or it is like brighter orange, etc. So you use these 2 approaches to explain the what question in science. Now that we understood the terminologies, the limitation 2 says that non-reductivity in the what part. Using the first example that we talked about, if you start with what is this? It is a stone. What is this stone? It is nothing but bunch of molecules. What is this molecule? Bunch of atoms. What is each atom? You keep going like this until you reach a point where you do not know what more to say. So you continue to reduce until we hit fundamental entities. In the world of science, these fundamental entities are energy, space-time, charge, etc. An analogy for this would be to look at our language, say the English language. It's made up of 26 alphabets. So if I read out a sentence, say the sentence up at the top, so it is broken down into words: scientific, method, limitations. But when I look at each word, if I ask you what is limitations, it has some meaning. But if I say what is L, what is I, you cannot go any further than that. So you do hit a roadblock, and that is a fundamental entity. So when science takes up this non-reductivity, the reductivity approach, it reaches the point where you cannot reduce anymore. That is the non-reductivity. The third limitation is the description of reality and not necessarily an experience of reality. For example, we know if you look at the atom, it is nothing but a central core nucleus with the electron cloud. Basically, mostly empty space. 99% of the space around an atom is empty. So, what is this table made up of? It is made up of atoms. If 99% of an atom is empty space, then the solid table seems to not mirror what our understanding is of the underlying concepts. So this is where reality and experience, right, is counterintuitive to your assumptions. So when you are experiencing a solid table, you lead to questions and further questions until you hit abstract terms and you start being in the world of shadows, as one of the scientists mentioned. So when you move, especially from a macro view to a micro view, from a macro world to a subatomic world, reality is no longer well defined and it does not match our intended experience. Science is not able to explain this behavior. And finally, subjective aspects are completely excluded. We all know that. So when you look at verifiability as a concept, you can view it under three layers. There is an objective verifiability, which is strictly the focus of science. There is also subjective verifiability, which is the realm of yoga. When I experience something in my meditative state, and you experience the same as well doing the same meditative technique, then you and I have verified to each other. This is subjective verifiability. Then there is the whole other realm of faith, which is taken at face value, right? You hear the word of a mystic who explains what happens when you are in a super conscious state. So you take that at face value. You do not question it, because unless you reach the state of the mystic, you would be unable to verify it for yourself. So therefore you take it as truth just because it is said so by a person of authority who has every experience and credibility that goes with it. So science consciously has taken the stance that it would not take subjective verifiability or any other aspect such as faith. Let's take a moment to look at how the scientific method can be applied to the process of meditation. Just a few seconds ago, I mentioned how your meditative experience and my meditative experience can be subjectively verified. So, if you were to make this as a scientific method, how could we run such an experiment? This is explained by Glenn Keswer in his book Meditation, Oneness, and Physics. So, he says there is an observation. Then, this observation leads to a hypothesis. This hypothesis is then leading to a test or an experiment to validate the hypothesis. You reach a conclusion from there, which ultimately in the process of meditation should help you increase your knowledge. You don't run an experiment just for the sake of doing it. There has to be a consequence of knowledge growth. So if this is the cycle in which you view the scientific process, then the observation in the world of meditation could be something like this. Our ancient seers had observed themselves and the people around them. What did they observe? Maybe their observation was twofold. They observed that every human being is seeking happiness. However, those who seek happiness from objects and experiences become disillusioned and inevitably they suffer. So these are the classic observations. So he brings up the question. So this observation begets a question. He says, could happiness be something not outside oneself? Because that's what he has observed from his the prior points. So he comes up with this hypothesis of oneness. He's saying that there is a state of consciousness where one is free from suffering, because there is the other state that people are in, which definitely does not provide this feeling of oneness. So there should be a feeling free from suffering realm that one should be able to reach. So he says, how could you do that? He says, let's use the method of meditation, because meditation is about going into oneself, observing the self and going in. While I cannot seek happiness moving out, what if I go in? Will I find that peace? So he runs this experiment both with himself and with others, and he solicits feedback. And what does he find? His feedbacks all concur. They all say that those who meditate experience oneness, the fourth state of consciousness, which is what we call turiya. And he says his hypothesis that there is a state of consciousness where one can be very much at peace cannot be rejected, because if 100 people participated and 100 of them experienced it the same way, then it means that this hypothesis has been verified. So he comes back to his observation with an increase in knowledge, and he says this knowledge that the true nature of universe is nothing but oneness, and being in oneness helps one to live a life of peace without worries and agitations, and therefore a lesson learned for humanity. This is how Keswer explains the method of science applied in a subjective verifiable experience. Before we close out the chapter, close out this specific section, there is one more nice thought experiment that was conducted in the 1980s, which could be of some value to us in this yogic work. This came from John Searle in the 1980s. He was an American psychologist. When he devised this experiment, this thought experiment, it was for a completely different purpose. But I believe Vasu sir brought this specific example into this coursework to highlight a key concept and a key reminder for all of us. Before we take to the conclusion, let's understand what this thought experiment is about. And in case any one of you is not familiar with the word thought experiment is basically a mental model. You imagine a situation and you wonder all in your mind what would be the outcome and what is likely to happen. So you use the world created in your mind to run this experiment. And thought experiments are a very powerful way to test out concepts. Sometimes those concepts cannot be tested in reality, or it might take a while to do such an experiment. So you do a mental model. We all do that as part of our normal life. However, this is a very structured way in which science also approaches. So thought experiment is a often used methodology in science. So what is this Chinese room thought experiment? Imagine that there is a room completely shielded in all directions. So no one knows, people who are outside, no one knows what's going on inside. And this specific room is supposed to be a Chinese to Chinese translation service. So people will drop off their inputs on one side and they can move down to the other, and they would get a word to word translation on the other output side. And a person is sitting in here. Think of this man as an American who does not know a word in Chinese. He does have a translator that he uses. So when a word drops in here, he quickly searches for that in his big giant ledger, big rule book. He finds the perfect translation for the word that dropped in, and he writes the output and drops it in the panel. And the person who made that request gets his answer. Let's say this person has been at this job for quite a while. This American doesn't understand a word in Chinese, but he knows whenever he sees a certain word come in, he knows which page number to look for and he becomes quite good at it. But the person outside doesn't know that this man actually is ignorant of Chinese. He would assume that this man knows Chinese just because he is able to give a word to word translation. At the end of the day, this man in the center, all he does is just replacing one symbol with another symbol. He has no subjective experience of the word that dropped in. If someone had dropped in the word consciousness, he would have probably given this translation or this translation of an output, but he would not even have known what this word means, so he didn't have a subjective experience of this word as he provided his response. So there was no real understanding. He has become efficient in translating because he now knows how to use the ledger book, but he is just doing a symbol to symbol translation. What is the lesson learned for us in yoga? The classic way in which people throw out terminologies of jivatma, paramatma, this is better, that is superior, this is the experience of a jivatma, so on. These are words that most people throw out without truly understanding what it means. Most of us have become this man in the Chinese room, using words but never really understanding what those words mean. Food for thought, huh? One of the important points as part of block 1 is to realize that science is not the be all and end all. There is this limitation to science that we all need to acknowledge. And this was very beautifully explained in the book Science Delusion by Dr. Rupert Sheldrake. There is an YouTube video that I would recommend all of us to watch, where he walks us through his book and the key concepts from his book. The book has these following chapters, and he takes the basic assumptions of science, he calls them dogmas, and he refutes each one so very eloquently that it makes us sit back and wonder whether science is as robust as it seems to be. Because with more knowledge, we are coming to realize that there are a lot of gaps in science, and therefore we need to acknowledge the gaps also while we support science for all its strengths. A short 5-minute clip from the full YouTube video is posted here. Let's roll it.
The science delusion is the belief that science already understands the nature of reality in principle, leaving only the details to be filled in. This is a very widespread belief in our society. It's the kind of belief system of people who say, I don't believe in God, I believe in science. It's a belief system which has now been spread to the entire world. But there's a conflict in the heart of science between science as a method of inquiry based on reason, evidence, hypothesis, and collective investigation, and science as a belief system or a worldview. And unfortunately, the worldview aspect of science has come to inhibit and constrict the free inquiry, which is the very lifeblood of the scientific endeavor. Since the late 19th century, science has been conducted under the aspect of a belief system or worldview, which is essentially that of materialism, philosophical materialism. And these sciences are now wholly owned subsidiaries of the materialist worldview. I think that as we break out of it, the sciences will be regenerated. What I do in my book, The Science Delusion, which is called Science Set Free in the United States, is take the 10 dogmas or assumptions of science and turn them into questions, seeing how well they stand up if you look at them scientifically. None of them stand up very well. What I'm going to do is first run through what these 10 dogmas are, and then I'll only have time to discuss one or two of them in a bit more detail. But essentially, the 10 dogmas, which are the default worldview of most educated people all over the world, are first that nature is mechanical or machine-like. The universe is like a machine, animals and plants are like machines, we're like machines. In fact, we are machines. We're lumbering robots, in Richard Dawkins' vivid phrase, with brains that are genetically programmed computers. Second, matter is unconscious. The whole universe is made up of unconscious matter. There's no consciousness in stars, in galaxies, in planets, in animals, in plants, and there ought not to be any in us either, if this theory is true. So a lot of the philosophy of mind over the last 100 years is trying to prove that we're not really conscious at all. So the matter's unconscious, then the laws of nature are fixed. This is dogma 3. The laws of nature are the same now as they were at the time of the Big Bang, and they'll be the same forever. Not just the laws, but the constants of nature are fixed, which is why they're called constants. Dogma 4, the total amount of matter and energy is always the same. It never changes in total quantity, except at the moment of the Big Bang, when it all sprang into existence from nowhere in a single instant. The fifth dogma is that nature is purposeless. There are no purposes in all nature, and the evolutionary process has no purpose or direction. Dogma 6, biological heredity is material. Everything you inherit is in your genes, or in epigenetic modifications of the genes, or in cytoplasmic inheritance. It's material. Dogma 7, memories are stored inside your brain as material traces. Somehow everything you remember is in your brain in modified nerve endings, phosphorylated proteins. No one knows how it works, but nevertheless, almost everyone in the scientific world believes it must be in the brain. Dogma 8, your mind is inside your head. All your consciousness is the activity of your brain and nothing more. Dogma 9, which follows from dogma 8, psychic phenomena like telepathy are impossible. Your thoughts and intentions cannot have any effect at a distance because your mind's inside your head. Therefore, all the apparent evidence for telepathy and other psychic phenomena is illusory. People believe these things happen, but it's just because they don't know enough about statistics, or they're deceived by coincidences, or it's wishful thinking. And dogma 10, mechanistic medicine is the only kind that really works. That's why governments only fund research into mechanistic medicine and ignore complementary and alternative therapies. Those can't possibly really work because they're not mechanistic. They may appear to work because people would have got better anyway, or because of the placebo effect. But the only kind that really works is mechanistic medicine. Well, this is the default worldview, which is held by almost all educated people all over the world. It's the basis of the educational system, the National Health Service, the Medical Research Council, governments, and it's just the default worldview of educated people.
So there you got it. As I said, this is just a 5-minute clip. The full YouTube video goes into much more depth on a few of the points that he raises here, and the book is definitely worth reading to get an alternate view on what science is all about. So that brings us to a formal closure to our block 1. So we will be the value system of science, the first portion of block 1, and we will move into the other sections in subsequent videos.